This tutorial is going to cover something very important in Grasshopper called tree structures and data structures. These are very pivotal to how you work with lists of data, and they can, once you understand them, they can be a very powerful tool. But this is only going to be an intro into data structures. I'll probably do another video at some point later on going a bit deeper into how they work. For now, we're going to start by making 8 curves. Actually, we'll make 6 curves in Rhino. So, make one here. One here. One here. One there. One there. And one there. Now, I haven't made them very different, but that's not too much of an issue for just demonstrating how this actually works. So what we're going to do is we're going to reference these in as 2 different sets. So we'll start, I'm going to set multiple curves, not one curve. So we'll select this one, and this one. And then we'll select this one, and this one. So now we are going to try and loft these curves together. And so immediately we can probably tell this isn't the result that we wanted. And that's because basically the structure of these 2 inputs does not match up. So if we look what's coming in over here, we have 6 curves in one list, and so Grasshopper is going to try and loft between all 6 of them. So what we need to do is we need to click this graft function over here. So when we graft these components, you'll see they now link up with each other. Now what you also may notice is that these 2 sets of curves over here cross over, and I did this on purpose to illustrate something in Grasshopper. It's very important which order you bring curves, curve geometry, or just geometry in general into Rhino. So I'm going to reset these curves over here in the correct order that I wanted. And so now we have 3 proper lofts. Alright, so a great way to understand data structure is the type of line that comes out of a component. So we'll start off by make a copy of these, and I'm going to ungraft it. So if I just take a list item out of here, you'll notice that you have this double dashed line, and that indicates that we have a list of geometry, as opposed to a single line, which indicates that there is only one geometry item coming out of that input. So a single line for one input, a double line for one list, and then we have this dashed line, which indicates that there are multiple lists, and that we can see by getting a parameter, a panel out. And this, the way that we understand, if we have multiple lists, that is called a tree structure, and tree structure is denoted by these numbers up here in the top right corner of the panel. Each of these is a brand new tree, and each of these trees have a list of items, and each list only has one item. But a better way to look at tree structure is through this through this component here called the param viewer. If we plug something in, it'll tell us the tree identifier number, which is exactly the same as what we saw in the panel here. So 0, 0, 0, 1, and 0, 2, you can see those line up, and it also tells us the amount of items in each tree. Alright, so now if we were to, let's say we wanted to divide these curves up. And I'll get rid of the loft and I will ungraft them for now. So we'll divide both curves, or both sets of curves, and then we'll make lines between them. And so what you'll notice is that this double line, which indicates a list of data, turns into a double dashed line as we take it out of the division component. And this is because Grasshopper realizes that the same structure cannot be kept across these components. Where we had a list of 3 items, it was alright to have them in one list, but those 3 curves each are divided into 10 points, which means each of those 10 points now rest on their own branch of the tree, resulting in 3 trees, one for each curve. And so that means that when these branches line up properly, then we'll get a proper matching of lines as our output over here. As you can see, all 11 of these points match up with all 11 of these points. Same thing on this second set of curves, and same thing on this third set of curves. Alright, now there's still more to data structure. What could we do? We'll we'll create a list of points, and so we'll bring back our series component. So the default values are absolutely fine for what we want to do, starting at 0, step size of 1, and a count of 10. Maybe I'll increase the step size just for visualization purposes. Okay. So at the moment, these 10 points that we have, we're basically lining up our x value with our y value, 10 in each, resulting in 10 points which form a diagonal line. But if we were to, say, graft one of these outputs, what we now get is 10 lists of data in our x component and 10 items of data in our y component. And so what Grasshopper does is it matches each of the 10 y values to every single list in the x value, and so we get 100 points at the end of that. And that's a brief look at data structures.